In our microcontroller course, the first topic that we are covering is the introduction to microcontroller. In our first video, we discussed what is a microcontroller and we define the meaning of a microcontroller, and we discuss some few microcontrollers. And now in this video, we are going to look at the types of microcontroller, especially with the classification of microcontroller, and we'll move on to discuss the difference between a microcontroller and a microprocessor, and finally we will look at some application of microcontroller in the embedded system. Now we will discuss the classification of the microcontroller. Although we know that we have many microcontroller, they have similar operation. That means they normally perform tasks in which they act as a computer on its own. However, there are a variety of microcontrollers that are classified based on number one, which is the number of bits. And we will mostly base our discussion on the number of bits. Now we can see that our first classification is the number of bits, and microcontrollers are classified based on the memory, and microcontrollers are also classified in terms of the instruction set. And finally, we say a microcontroller is classified based on the architecture. And the family of microcontroller, we have the 8051 Motorola, PIC, Texas, ARM, Siemens, Philips, Atmel, and Intel. Most of these are the family in which the microcontrollers are mostly derived from. Now, because the main idea is that each of these microcontroller classified based on the type of the bits. That means it can be classified whether it is made up of 4-bit, 8-bit, 16-bit, and 32-bit. And what does that mean? And why do we need microcontrollers to have varying number of bits? And firstly, you should be able to know what do we mean by a bit. And we know that a bit represents a state 0 or logic 0 and the 1. And in most cases, we normally had the term which can be logic low, and we have the term binary 0 and a voltage which is towards 0 volts. However, when we have the 1, what does it mean? We sometimes call it the logic high, and we normally have the binary 1, or it has a voltage which is almost 5 volts. And those represent what is called a bit. And when we say bit, we are referring to either a state which is 0 or 1. And by understanding what is a bit, now we can look at the 4-bit. And what does that 4-bit mean? When we look at the discussion in which we normally understand a decimal value, and this decimal value can be converted to binary, and this bit 0 and 1, they are represented using a binary representation. Now, in terms of this binary representation, now let's say 2 to the power of n in binary, where we can say the n equals the number of bits. And by understanding that, we now should have 2 to the 4 number of bits. We should have almost 16 combination of the output in which the 4 bit can produce. And this 4 bit will range from 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, all the way to 1, 1, 1, 1. And with the combination, this can be the first combination, this can be the second, this can be the third, and this can be the 16th combination. And we start the count for 0 all the way to 15. And if you convert this one, you should get in terms of the decimal, which is 0. And in that case, you should have 1. In here, you should get 2. And 1, 1, 1, 1, you should be able to get 15. And you can see from 0 all the way to 15. So these are the combination in which this particular microcontroller may have. And when we look at this microcontroller, let's say MCU, which have 4 bit. So this 4 bit is telling us that this microcontroller can be able to process 4 bit at a time. Therefore, in 1 second, this microcontroller can be able to handle 4 bit at a time. And because this microcontroller normally have inputs and it produces the output, and this input and output can be in terms of analog or a digital signal. And when the microcontroller itself, it normally process inside its processor, it will produce and process 4 bit at a time. And this is why this type of microcontroller is known as a 4-bit microcontroller. I will later explain the difference between the speed and the application in which this type of microcontroller can be used. And we can simply say that a 4-bit microcontroller will have a binary range from 0000 to 1111. And in terms of the decimal range, we can see that it starts from 0 to 15. And this is just the same, but we normally do conversion. So both the binary and the decimal are the same, but the difference is that the binary can be in a binary number system and decimal is in terms of a decimal number system. And in our discussion for the number conversion number and the codes, we know that a decimal have a base of 10. However, the binary, it has a base of 2. So this is the only difference. Because we human can understand a decimal, however, the microcontroller will only understand a binary. Therefore, we have to convert our decimal understanding into the binary understanding so that the microprocessor can now be able to understand the binary representation of the number system. And so similarly, we have the microcontroller having 8 bits. That means from our previous definition, we know that a particular microcontroller can be able to process 8 bit at a time. Now, in terms of the 8 bit, we now should have 1, 2, 3, 4, 5, 6, 7, 8, and we have 0, 0, 0, 0, 0, 0, 0, 1, and we have 0 0 0 0 0 0 1 0 all the way to 1 1 1 1 and 1 1 1 1. Now we know that we have 2 to the power 8, which will now gives us 255. And with the number of bits, it will be, for example, 256 when we count from 1 to 256. And 255, we can start from 0 to 255. And this range is 256, same as this one, 256. Only the prefet is that we count the number of bits starting from the 0 and end in 255, such as in this case we normally have 0 to 15. So this we have 1 to 16, and in most cases we normally have a 15 combination. Therefore we start from 0 to 15. So in case you might wonder where does the other one goes, because in most cases we normally count from 0 and to the maximum value. So we can see and compare from our previous microcontroller that our previous microcontroller can handle 4 bits at a time. And now we have a microcontroller that can be able to process 8 bits at a time. So we see that there is a increase in the number of bits. That means the number of bits represent the information that can be processed. Increasing the number of bits meaning that we can increase the number of data or information that can be processed in a microcontroller. And later we will look at some example of a big microcontroller and the Atmel microcontroller, and especially with the 8 bits, and we can do some comparison for you to really understand what does that bit mean and how can you locate in a microcontroller. And we have the other one, which is the 16-bit. And in terms of the 16-bit, we know that it will begin from 0 0 0 0 0 0 0 0 0 0 0 0 and 0 0 0 0 and 0 0 0 0 0 0 0 0 0 0 0 0 and 0 0 0 1 all the way to we have 1 1 1 1 1 1 1 1 1 1 1 1 and 1 1 1 1. So the decimal range can be from 0 all the way to 65,536 number of bits. So we can see the decimal range. It can now be able to process more and more data. And in this example, we now have a microcontroller that can be able to process 16 bits at a time. That means more and more information can be processed in this microcontroller. And the same we can see for a 32-bit microcontroller. And we can see that for a 32-bit microcontroller, it can start from 0 0 0 0 all the way to 0, and we have 1 1 1 1 all the way to 1 1 1 1, and all these bits can be 32 in total. And in terms of the decimal range, we have from 0 all the way to 4 294 967 and 296, and this is the range for a 32-bit microcontroller. And because those microcontrollers, they have a range in which they process data. Imagine we have a computer which have 64-bit 128 bit, and in most cases, for example, if we look at 128 bit, we now have what is called a supercomputer. So a supercomputer will be able to produce 2 to the power of 128 bits. So you will have more and more data that can be processed one at a time. That means it is super fast because it can process more data. And when we look at this particular microcontroller, we can see that when the number of bits increases, we can be able to see that the number of information that can be processed is increasing. And when we decrease the number of bits, we can see that it decreases the number of bits that can be processed inside a microcontroller. And I believe you can be able to fully understand why a microcontroller is classified in terms of the number of bits, because different number of bits may differentiate between each of the microcontrollers that are available in the market. And now we will look at the second classification, which is the memory, and how is the memory makes the microcontroller different from each other. A memory in a microcontroller can be external or embedded. Imagine we have a microcontroller, and inside this microcontroller we have the embedded memory. That means this memory or a memory circuit is built inside a microcontroller itself. And when we have the external memory, that means a memory that is not built inside the microcontroller, and it can be outside, but later it can be connected to a microcontroller. And this is the main difference in which you can be able to understand why we have the microcontrollers having external and embedded memory. Now I will give you some example and we can discuss those memory, either it is an external or the embedded memory. And let us begin with the embedded memory. So what is the embedded memory? As we have discussed, it is the memory that is built into the microcontroller chip. And this embedded memory, since it is inbuilt, we can also call it as internal memory. And one example of such memory is the flash memory. So flash memory can be an embedded memory where the function of the flash memory is to store the firmware or the application code. And this type of memory is a non-volatile memory, meaning that it will retain the data after the power is switched off. And one example is we have the ESP32 microcontroller, which have up to 4 megabytes of this embedded flash memory. And this type of flash memory stores the firmware, or we can say this flash memory is nothing but the program memory, and it normally stores the application code or the firmware. So this type of memory, when the power is off, when we remove power from this memory, whatever memory that is stored will be kept. And in case where a ESP32 microcontroller have 4 megabyte of this type of flash memory, anytime you program the instruction into a particular microcontroller inside this memory, you are now storing the instruction code that can be used later on to enable this microcontroller to perform a specific task. And the other memory is known as the SRAM. And this type of memory is known as a data memory. So when we look at the static RAM, we know that the RAM is nothing but the random access memory. And this type of memory will hold a data temporarily. Therefore, we can be able to say that it is used for only a runtime or stack or delete, because when this microcontroller is in operation, data will be flow in and out of this particular microcontroller, and this RAM is used to temporarily stores the data. So this type of memory, apart from a non-volatile, we can say it is a volatile memory, meaning that the data will be lost when power is off. So this memory, the SRAM, can also be an internal memory of a microcontroller, and since it is under embedded memory, that means those memories such as flash memory and the SRAM memory can be inbuilt inside a microcontroller. And we can say thirdly, the EEPROM, and we have the CPU registers, and registers is also a memory because it is a sequential circuit. And later we will discuss what is EEPROM is known as electrical erasable programmable read only memory, and we will discuss in detail what is the EEPROM, and we can also discuss what is a registers. So those are some example of a memory that can be an embedded or internal memory of a microcontroller. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.